Hi, grade 8 ladies. This is day 5, lesson 9-5, page 463, numbers 11 through 39, the odds. Please, as we've done in the past, pause this in a few seconds and take a look at pages 461, 462, 460, 461, and the top of 462, and then come back to this video and we'll look at some examples. Okay, so this lesson's about the Pythagorean theorem. Some of it's review, but some of it is new. We know that the Pythagorean theorem states that a squared plus b squared equals c squared. We've done these kinds of problems in the past, but just a reminder that the a and the b are the legs of a right triangle. The legs are the two sides that make up the right angle. The hypotenuse, or the c value, is always the longest side, and it's always the side that's furthest away from the right angle. And the hypotenuse has nothing to do with making the right angle. So in the case of this particular problem, to start off with, we know that the legs are 6 and 8. We're going to square them, and together they make c squared, or the hypotenuse squared. We have 36, 64, 100 on the left side. And now what do? Well, we need to figure out what this c is, not what c squared is. So we take and we do the exact same operation to both sides. We take the square root of both sides, and we get a 10 as our value of c. What about a problem in which we're given the c value, 25, and we're given the b value, 20, but we're not given the a value? Well, same type of problem. Let's see, is this going to fit on the board? Hopefully it will. A squared plus b squared, which is 20, equals c squared, which in this case is 25. Does that fit? Yes, it looks like it does. 20 squared is 400. 25 squared is 625, and a squared is still a squared. How do we get a by itself in this case? We're going to subtract 400 from both sides, and when we do that, we get an a squared of 225. We then do the same operation of taking the square root of both the left and the right sides, and we get an a value of 25. So our a here is 25. Look at this line right here. We are told that a is 9, b is unknown, and c is 41. Well, we'd solve it the same way. A squared, 9 squared, plus b squared, unknown, equals c squared, 41 squared. 9 squared is 81. I don't know what 41 squared is, so we'll do that off to the side here. I get 1681. We're going to subtract 81 from both sides of the equation, and then take the square root of both sides, and our b value equals 40. Did that fit on there? No, it didn't. Got cut off a little bit. Now take a look at the next problem. It might just throw you for a little bit of a loop, because the a value is unknown and the b value is the square root of 123 and the c value is 22. This is something new for us. What do we do with problems where the length of a side is given with a radical sign, square root of 123? Well, let's take a look at this problem. A squared plus b squared, we're going to have to square this, equals c squared, which in this case is 22 squared. This is easy enough to solve, right? We take 22 times 22, and we get, who knows what, we get 484. But how do we square the square root of something? Well, let's do a simpler problem first. If I said to you, what's the square root of 36? You'd say it's 6, right? And if I said to you, what is 6 squared? You'd say that's 36, wouldn't you? Yeah. So if I take this 6 and I square it, I get 36. But guess what? This is equal to this. So if I take this and I square it, I also get 36. The square root of 36 squared is 36. Or for that matter, if I write up here the square root of 45 squared equals 45. Or in this case, the square root of 123 squared is 123. So how do we proceed here? Well, the square root of 123 squared is 123. And we write it like that. Now we're going to subtract 123 from both sides of the equation. And when we do that, we get 361. At this point, we're going to take the square root of both the left and right sides, and we get a over here. I don't know what the square root of 361 is, so let's do a little guess. Maybe it's 19. Let's try 19 times 19 and see what we get. Yeah, I get 361. So the square root of 19 is, or square root of 361 is 19. So our a value in this case is 19. Any questions? So, well, here I go again, saying that dumb question that can't be answered. But you can still give me a call. You know the phone number. It's been on every video so far. What about how are we going to handle problems from 28 to 33? From 28 to 33. There, the directions say the lengths of three sides of a triangle are given. Determine whether each triangle is a right triangle. I'm going to do problem 30 with you right now. 30 says, what if we have an a value of 18, a b value of 24, and the c value is 30? Do you remember that assignment dealing with the finding of Pythagorean triples? That's what this section's all about. What we do is we say to ourselves 18 squared plus 24 squared, does that equal 30 squared? If it does, we're going to write yes, because yes, these three numbers make a Pythagorean triple. If they don't equal, if the left side is not equal to the right side, then we're going to write no. Let's see what happens here. 30 squared, I know that that's 900. 24 squared, I don't know that one. I think it's in the 500s, 596 or 576. Not quite sure. Oh, 576. And what about 18 squared? 46081, 423. I get 324. If I add these two together, let's see what I get. I get 900. So the answer to this problem is yes. These three numbers do create a right triangle. They are a Pythagorean triple. I hope this helps you today. Again, if you have any questions, give me a call at 517-242-3138, and have a good evening.